A second type of inorganic compounds are molecular compounds. And so today we're going to focus on the molecular compounds. But first we're going to do a little compare and contrasting. So in the last video we looked at ionic compounds. Ionic compounds are arranged in a three-dimensional array of alternating positive and negative ions. So we have basically a positive by a negative, positive, negative, positive, negative, positive, negative, and so on in like a 3D almost crystal structure. And that you can almost think of as a geometric shape. They do not have individual molecules, and we use the empirical formula to represent their chemical compound. Molecular compounds, they actually form molecules, and they share their valence electrons when they bond, and the bond will form between pairs of electrons. And here we look at their molecular formula. And so we are going to focus on how to write the molecular formulas. So when we name a binary molecular compound, remember bi means two. So a binary molecular compound is a compound with only two elements. We use the molecular formula. Oh, and here's your definition of binary molecular compound. It's a molecular compound that is composed of two elements. This will happen, the two elements will be two nonmetals. And we use prefixes on the names to communicate the number of each element. Oftentimes when we have binary molecular compounds, two elements, since there's only two of them, they will often combine in different ratios. So for example, we can have methane, which is CH4, or sorry, let's do a different example. Let's do carbon monoxide. Is CO, but then carbon dioxide is CO2. So we have the two elements, two of the same elements, combining in different ratios. In carbon monoxide, we have that 1-to-1 ratio, and in carbon dioxide, we have a 1-to-2 ratio. So when we use prefixes, we use these number indicating prefixes. I feel like you should be fairly comfortable with these. And again, you will not get this chart. This needs to be memorized for the tests and quizzes. So general rules, when you are naming these compounds, you are going to write the less electronegative element first. The exceptions would be that carbon is always written first, and that hydrogen is always written after nitrogen. So just a couple exceptions there. The first element in the formula is written first in the name of the compound. And so no prefix is used if there's only one atom on that first element. So like when we did carbon dioxide, notice how there's only one carbon, but we still only wrote it as carbon, and then the prefix di showed up because of this 2, and then oxide for the anion. The second element is named after the first, meaning it's written second. The ending changes to "ide", and the prefix mono will always be used. An A or an O at the end of the prefix is usually dropped when the name of the element begins with a vowel. That's kind of like the oxide thing. And so we can do a couple examples. We could have, let's say, NO. If we wanted to name that, you write the first element is nitrogen. Again, we didn't write mono because it's the first element, but then we would write monoxide for the oxygen. If we were going in reverse, if I gave you carbon tetrachloride, you would write the element name, carbon. There's only one, so we don't write the subscript. And then chloride is Cl, and the prefix tetra tells you that there's 4 of them. We could do another example, disulfur, dichloride. And so sulfur is the element there. Prefix di indicates 2. And then chloride is Cl, again di telling us 2. So our compound chemical formula for disulfur dichloride is S2Cl2. So our molecular compounds are a little more simple when it comes to naming them, as long as you know your prefixes and the numbers that are associated with them. And then back up here with the electronegativity, generally speaking, carbon, phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and fluorine is the order of electronegativities. And that's, again, generally speaking. But it at least is a list that gives you a starting point.